Hello everyone, today in this video we'll be discussing the module 4 of machine learning, and in this video I have the following topic which is related to calculating the probabilities using the Bayes theorem, and we have the artificial neural networks. And make sure you watch this video till the end. Easily you can score more than 80% marks if you watch this video till the end, because I'll be discussing all the important topics you need to know and how do you remember them. And please do like and subscribe, it helps me make more videos like this. So without wasting more time, let's get started. If you have any question, you can DM me on Instagram here. Now, the first topic is introduction to Bayes theorem. Okay, Bayes theorem is based on probabilistic learning. Based on probabilities, you'll be learning something. Okay, probabilistic learning combines prior knowledge with the observed data. We know something about a thing, and by observing this, we know something. Okay, by using these two, we'll be predicting the behavior of this. That is called as probabilistic learning. So there are three fundamentals of Bayes theorem. Okay, we need to know what is prior probability, likelihood probability, and posterior probability. Prior probability is nothing but it is the probability of something which we already know. Okay, before any new information is collected, we know something about it. Okay, like an apple is usually red color. That is the prior probability. Okay, likelihood probability is when we observe it and get to know some things. Okay, after observing apple, we get to know there are different types of apple, like the green, yellow apples. Okay, and what is posterior probability? This is after calculating or applying the formula. Okay, posterior probability is nothing but prior probability plus new evidence. Okay, so when we add these two, will be getting posterior probability. Okay, now there is a formula for that. So hypothesis is nothing but which we assume whatever is the case, and evidence is what is observed. Okay, so to calculate the posterior probability, we'll be using this formula. Probability that evidence is there given hypothesis is true into probability of hypothesis being true divided by probability of evidence being true. So this is called as maximum a posteriori hypothesis. Let's understand this using an example. Now there is a boy who has a volleyball tournament. Okay, there is a boy in a school who has what, a volleyball tournament. Okay, now what, he today he feels sick. Okay, it is unusual. There is only 40% chance that he would fall sick since he is the healthy boy. Okay, so 40% chance of sickness. Okay, that is the thing. Probability of he being sick is 40%. Okay, next is find the probability of the boy participating in the tournament. The boy is very much interested in volleyball, so there is 90% probability that he would participate in the tournament and 20% that he would fall sick. Okay, so boys participating in the tournament, that is 90%, he falling sick is 40%, and the probability given that boys participating in the tournament even though he is sick, that probability is 20%. Okay, now what you have to calculate is the probability of boy participating in a tournament given that he is sick. Okay, see, don't confuse it with this. This is what we are sure that he will participate in the tournament, and what is the probability that he will be sick. This one is reverse. This one is given that he is 600% that he is sick, what is the probability that he will participate in the tournament. It is reverse. Okay, so we will be writing the probability of a boy participating in the tournament given that he is sick. If you have to calculate, we will be multiplying probability of boy participating in the tournament into probability of he being sick given that he is participating in the tournament divided by probability he is sick. This is the same as this one. Okay, so here the evidence is this one. We will be taking the hypothesis as boy is participating in the tournament, and evidence is he is sick, because we are sure that he is sick, right? So evidence will be he is sick. So when we apply those values which are given here, 0.9, 0.2 and 0.4 in the respective formula, we will be getting 0.45. So it is 45% that he will participate in the tournament given that he is sick. This is how the Bayes theorem works. Now based on this, there is an algorithm called as naive Bayes algorithm. It is a binary or multi-class algorithm that works on the principle of Bayes theorem. Okay, it classifies based on collective value of all the probabilities of all the features. So every time it is not just that he will be sick or not. Okay, there can be many other factors like slightly sick, moderately sick, more sick, extremely sick, like that. Okay, so there will be many different features will be there. We have to consider all those features and find out the probability. So let's take an example and understand. So here, see, there are different kind of features like CGPA, interactiveness, practical knowledge, communication skills. There are 4 features and one target is there. Means if the person has CGPA as greater than or equal to 9, interactiveness is there, and the practical knowledge is very good, and the communication skill is also good, then the job offer is means that person will be getting the job offer. If it is these things, person will get the job offer. If it is greater than or equal to 9 but interactiveness is not there, practical knowledge is average, communication skills is poor, then person will not get job. Like that, it is having the data. Okay, now we have to use the naive Bayes algorithm to find out our test data. Okay, test data could be like there is CGPA of 8, okay, and interactiveness is no, and practical knowledge is very good and communication skill is moderate, if that kind of data is given, will that person most probably get a job or not get a job? That we have to find out using this data. Okay, so for that what we do, first compute the prior probability for target class. Target class means finally what we are trying to find out, that class. Okay, we are having these features and finally this is giving the output, so whichever is the output, that is the final class. So for the final class we'll be having job yes as 7 by 10 and job no as 3 by 10. Okay, means how many yes are there and how many no are there, that we have to find out the probability. So it will be 7 by 10 and 3 by 10. Next we have to compute the frequency matrix and likelihood probability for each feature. So there are four features, right? So for the four features you have to calculate the feature matrix and the likelihood probability. So how do we do that? So if you observe carefully, in CGPA you have three types of CGPA. It is greater than 9, greater than 8 and less than 8. So whenever CGPA is greater than 9, how many job offers are yes and how many job offers are no? Let's calculate. When CGPA is greater than 9, this is a job offer, yes. Okay, 1 1. Okay, here 2 1 and here 3 1. Okay, means 3 yes and 1 no, right? So that one will be writing here 3 yes and 1 no. Like that, when it is greater than 8, it is 4 yes and 0 no, and it is less than 8, it is 0 yes and 2 no. So we'll be adding up this, we'll be getting 7 total of yes, and here we'll be getting 3 total of no, right? 7 plus 3 is 10, that is the whole data set. Like that, we'll be calculating the frequency matrix. Using this matrix, we'll be calculating likelihood probability. For example, here we'll be just calculating the percentage. This is 3 by 7, this is 4 by 7, this is 0 by 7. Means we are just dividing 3 by 7, 4 by 7, 0 by 7. Here it will be 1 by 3, 0 by 3 and 2 by 3. That answers we are writing here. This is called as likelihood probability of CGPA. Like that, we'll be doing for the interactiveness also. There are two values of interactiveness, yes or no. In yes, how many job offers were yes, and in no, how many job offers were no. That I mean, in no, how many job offers were yes. Okay, means interactiveness was no, but job offer was yes. How many were there? That we'll calculate and keep. Then we'll find out the likelihood probability for both job offer yes and job offer no. Like that, we'll do for the practical knowledge and communication skills as well. After that, we have to apply the formula. Now, using the Bayes theorem, calculate the probability of all hypotheses. Now, the test data which they will give in the question, you have to consider that. Okay, so in the question they have given a person has CGPA greater than 9, interactiveness is there, practical knowledge is average, communication skill is good. Now we have to find out by applying the formula if this person will most probably get a job or not get a job. So we ignore the denominator, which is P of test data, since it is common for both the cases, right? We are comparing now. We are comparing the probability that this person will get a job or not get a job. When it is comparison, we just want which is a greater answer, right? We if we divide this by 10 and divide this by 10, still it will not make any difference, right? Whichever is greater, that will still remain greater even after dividing by some value. So with that division part we'll be skipping. Okay, so here we will be writing, given job offer is yes, means what is the probability that job offer is yes, and given the test data. Okay, so what is the test data? Test data is CGPA is greater than 9 and job offer is yes, into probability that interactiveness is yes given job offer is yes, practical knowledge job offer, communication skills job offer, and into P of job offer is equal to yes. You have to multiply all these things. Okay, when we multiply, we'll be getting an answer here. Similarly, we'll have to calculate for job offer is equal to no also, we'll get another answer here. If you compare these both answer, which is greater value, this is greater value. So in this case, the test data which they have given, most probably the person will be getting a job. Okay, that one will be calculating and keeping. That is how naive Bayes algorithm works. Another type of same thing is the Bayes optimal classifier. Okay, here also we'll be doing the same thing, but here it will be doing it using the most probable hypothesis. Okay, it chooses the most probable hypothesis. A new instance has to be classified. Okay, let's take an example and understand. Here four hypotheses are given. Okay, there are four people of the first one is here the value is 0.3 and COVID positive is 0 and COVID negative is 1 here. Okay, means the four hypotheses are there. If the patient is diagnosed as COVID positive or negative, we have to calculate. Okay, so here first is 0 and 1, positive is 1 and this is 0, 1 and 0, 1 and 0. Okay, so here 3 times yes is there and 3 times no is there here. So if we just observe carefully, we'll be able to see it that mostly the person might have COVID positive, because majority is 1 here. But that's not the only thing we need to see. We need to also see the weights associated with that. Okay, so when we see the weights associated with that, what we have to do is the negative value. Okay, P of COVID negative is 0.3 into 1, that is equal to 0.3. Okay, now the probability of COVID positive, for that what we need to do, 0.1 into 1 plus 0.2 into 1 plus 0.1 into 1. When you do that, we'll be getting 0.4. So if you observe both of them, which is the maximum value? The maximum value is this one, 0.4. So in this case, we'll be selecting that the person has COVID. Okay. So, but it might not always be the case. If what if once were more here, right? So and these values were lesser. Like for example, it was 0.05. So if it was 0.05, it will still not become greater than 0.3. So we have to calculate and see always. This is the optimal classifier. So the next one is the naive base for continuous attributes. Okay, so here what we'll be doing is we'll not have a single value like greater than 9, greater than 8 or less than 8. We'll be having some decimal values here. Okay, so based on the previous algorithm we cannot classify this because there are decimal values and all decimal values are different values. Okay, so now what you have to do, the thing which you can apply here is yes and no, the like the previous one which we did, yes or no, like that we calculated a table, right? How many yes are there and job is also yes is there, how many no are there, job is yes is there, same for no also, job offer is no and no here. That we can do for interactiveness, but for CGP you have to apply a formula using mean and standard deviation. So first calculate the prior probability for the target feature, which is job offer. That probability is 7 yes are there, 3 no are there, which is 7 by 10 and 3 by 10. Next we have to calculate the feature matrix and likelihood probability for each feature. First consider CGPA. It is a continuous attribute, okay, because all the decimal values are different there. So what we will have to do is calculate the mean and standard deviation for job offer is equal to yes, and mean and standard deviation for job offer is equal to no. Means how many yes are there in that CGPA, we have to calculate the average and find out standard deviation, and for how many no are there, we have to calculate the standard deviation and find out the calculate the mean and find out the standard deviation. The formula for calculating the standard deviation and the mean is given here. Okay, this is the formula. Okay, so here this is the standard deviation formula. N is the size of population, means how many values are there, so 10 values are there. Xi is each value. Okay, subtract it from the mean. How do you calculate mean? Add up all the values which has yes in the job offer and divided by how many values are there. Okay, means if 5 yes are there, calculate the CGP of all the 5 values and divided by 5. That will get the mean, and subtract mean with this and divide by n and take the square of this summation, then you will find out the standard deviation. Okay, like that the standard deviation and the mean is calculated for yes and no. Okay, next what you have to do, this is the as the previous one, frequency matrix for the interactiveness. We'll calculate yes and no, how many are there, find out the likelihood probability also. Now using the Bayes theorem, we have to calculate the test data for 8.5 CGPA is there and interactiveness is yes. Is the job offer more probably the person is going to get or not? Okay, now see, job offer yes, that probability given the test data. So what is the test data? 8.5 and yes. So 8.5 given job offer is yes, into interactiveness is yes, and given the job offer is yes, into pre of job offer yes. So to compute that, we'll be using this formula for CGPA. Okay, for CGPA job offer yes, for this part. Okay, the other part is straightforward like previous one how we did. For this you need to use this formula. Okay, xk uij and sigma ij, which is the mean and standard deviation. This is the individual value, which is the 8.5 here. Okay, now after this what you have to do is substitute the value of the sigma, which is standard deviation. CGPA is yes, that is 0.0581. Okay, and the value of the mean, which is 8.814 here, and 8.5 is the test data which they have given x of k. Okay, once you do that, you will get an answer 0.594. Like that same thing do for the no also, you'll get an answer 0.297. Now based on these two, which is the higher one? The higher one is 0. Which one? 0.594. But it's not just that, we have to also multiply it with interactiveness of yes, right? So if you multiply it with interactiveness of yes and then find out the final answers, we'll be getting two answers here for the values, which is here for the yes we'll be getting as 0.297, and for the no we'll be getting as 0.0369. Okay, so this is the more higher value, so that one will be considered. Okay, that was about the Bayes theorem. Next is next half of the module is related to the artificial neural network. Okay, so ANN is also the short form of artificial neural network. It is designed to simulate human brain, like how we think, like that we are trying to make the computer think. Okay, the below figure shows the human neuron and artificial neuron. Human neuron, how it works, the input comes from here and the dendrites collect that input and give to the cell body, and axon provides that values whichever is to be calculated, and the output comes from here. Okay, like that it is a biological neuron. Like that same thing it is designed in artificial neuron as well. Inputs are coming from here, the x1s are the input, the w are the weights. We'll be seeing what weights is in the upcoming topics. Cell body is here, it does the calculation, and output comes from here. Okay, so this is the artificial neuron. So there is a similarity between biological neuron and artificial neuron. So now the summation functions will be there, which will be used to calculate the actual final outputs, and here we have the activation function as well. So after it crosses a threshold value, whatever the answer comes, if it crosses a threshold value, either the answer will be 1 or 0 or true or false, like that. Okay, so there are different kinds of answers as well, which we'll be discussing. Like that we can have multiple neurons for the multiple types of inputs, and we can have multiple such layers. Okay, so this is a fully connected artificial neural network structure. Okay, now what is activation function? It is used to determine whether or not to fire a neuron. Okay, means the input comes. Okay, input comes, like for example apple. Okay, I'm seeing an apple, so in my mind I get the flavor of apple, the taste of apple, and the sight of apple, and the color of apple I'm able to see. So based on these inputs, if it is apple or not, how my brain will see. This is also strong input, strong input, strong input, and strong input. So overall input will be strong, means it is most likely an apple. Like that, based on the inputs and the weights associated with that, we'll be able to calculate if it is true or not. Okay, so activation function does that. So there are different types of activation function. It can be linear or non-linear. Okay, now the first one is identity or linear function, means the output will be equal to the input. Okay, and next is the binary step function, means output will be 1 or 0. When it will be 1, it will be 1 when f of x is greater than or equal to theta. If it is less than theta, it is 0. Okay, if it is greater than or equal to theta, it is 1, and here it is -1. This is the bipolar step function. In sigmoidal function, we'll be having this value here, which will be giving us an output in the range of 0 and 1. Bipolar sigmoid is the reverse of this. Okay, here in the numerator we'll be having this also, so it outputs values in between range of -1 and 1. This is 0 to 1, this is -1 to 1. Ramp functions, output will be either 1 or 0 or x value. Okay, tan h, it is another type of output function which is used for the vanishing gradient problem. Okay, and ReLU is the most used one, which will be having x if it is greater than or equal to 0, 0 if it is less than x. Okay, next is softmax function. This is also another type of function which is extensively used. Okay, so these are the different types of artificial neural network function activation functions. Okay, now perceptron and learning theory. Okay, so you need to know four things in the perceptron and learning theory. So here the first thing is inputs from the other neurons. Whatever you see as x here, that is the inputs. Weights and bias is this. Okay, weights is this and bias is this, means favoring one kind of output, that is the bias. Net sum is the final answer which we get. Activation function will be based on this answer. If it is greater than 0, it will be 1. If it is less than 0, it will be 0. So like that it will calculate 1 or 0, true or false. Okay, that thing the activation function does. This is the model of the perceptron. Okay, this is very important diagram. Next is we have the formula. Okay, this formula will be using to calculate the net sum. Activation function works on the value of net sum and bias. We will be finally getting 1 or 0 as the answer. Let's understand this using an algorithm and an example. Okay, now see, consider a perceptron to represent the boolean function and. Okay, and you know, right, when both are true, then only it will be true. Okay, 1 and 1, it will be 1. If it is 1 and 0, it will be 0. If it is 0 and 1, it will be 0. If it is 0 and 0, obviously it will be 0 only. So this is an AND function. Now we have given the initial weights. They'll give you initial weights. W1 is 0.3. This is also very important question. And W2 is -0.2. And learning rate is 0.2 and bias is 0.4. By using these formulas, you have to calculate the answer for the boolean function. Okay, you have to design a perceptron. How do we design a perceptron? Like this we'll design a perceptron, but this is not the accurate one. Why? Because we need to apply the formula and get the weights correct. These weights are the starting weights. Finally we'll get an updated weight. Okay, updated weights until the boolean function gives the desired output. Okay, so let me explain it to you clearly what's happening. Okay, in exam, what you have to do, you have to make this diagram first. Okay, the bias value will come here, and here we'll be writing step function. Here the W2 value will write, here the W1 value will write, and here is the input. Either it will be 0 or 1. Now, if it is 0 and 0, the desired output is 0, because AND function 0 and 1 also it is 0, 1 and 0 also it is 0, 1 and 1 it will be 1. Okay, so this is the desired output. Now using this weights, am I getting this output or not? That is my question. So how do we check it? We can check it using this one. 0 and 0, it should be 0, 0 and 1 it should be 0, 1 and 0 it should be 0, 1 and 1 it is 1. Now let's calculate and see. How do we calculate? We'll multiply x1 with w1 and x2 with w2. I repeat, we multiply x1 with w1, x2 with w2, and we'll add them up. Okay, so w1 is 0.3 and w2 is minus 0.2. So x1 and x2, we multiply them and add here, and we have to subtract, or it's not actually the subtraction, yes it is subtraction, we'll subtract with the bias. Okay, bias value is 0.4. So when you do that, we'll get some answer. Okay, let's understand what is the answer here. 0 into 0.3 is 0, 0 into minus 0.2 is 0, 0 minus 0.4 is minus 0.4. And what I told you, if it is less than 0, this value, the answer output will be 0. So an answer is written here as 0. If the answer I have got like 0.4, okay, if I get the answer positive 0.4, it is greater than 0. So my answer will be 1. Okay, like that I have to write. Now this answer we got as minus 0.4, so it is 0. And this answer 0 into 0.3 is 0 again. And 1 into minus 0.2 is minus 0.2. Minus 0.2, minus 0.4, minus 0.6. It is less than 0. So here I write as 0. 0.3 minus 0.2, what is that? What, that is 0.1. 0.1 minus 0.4 minus 0.3, this is also 0 only. And this one will be 0.3 and minus 0.2, that is equal to 0.1, and again minus 0.4, again it will be 0 only, because all these answers which I have got here, it is less than 1, so it will be 0 only. I mean less than 0, so based on that the answer will be written as 0. Now the desired output here, it is 0, and I am getting the answer here as 0 after calculation. That is fine. Here also 0, here also 0, that is fine. Here also 0 and here also 0, that is fine. Here I am getting 1 and here I am getting 0, that is not fine, because I should get 1 here. So error, how we will calculate, subtract this with this. 0 minus 0 is 0, again 0 minus 0, 0 minus 0, in both the cases it will be 0 only, and here 1 minus 0, that will be 1. So error is 1 here. Okay, now weight it will be 0.3, 0.3, 0.3, 0 minus 0.2 in these cases, and no change will be there, since it is having the final output here y estimated. Okay, that should be equal to y destination for all of the cases, then only it will be final answer, but it is not. Why? Because here I'm getting the value as 0 while it should be 1, right? So we have to update the weights. How do we update the weights? Okay, forget this for now. We have to update the weights. How do we update the weights? W1 delta we have to calculate and add to W1. Okay, calculate delta W1 and add to W1. You will get a new weight. Now for this input, okay, this input, what is the x1 value? 1. X2 value is 1. So you have to multiply the learning rate, which is 0.2. In the question they are given, right? And ET is nothing but this value, and x1 is nothing but this value. When you multiply them, you will get 0.2. Now w1 will become the initial value of w1 plus delta w. So initial value was 0.3, delta w is equal to 0.2, so it will be 0.5. Next, like that only you have to do for this one also. Okay, w2, for w2 it will be x2. Okay, same thing multiplied, 0.2 into 1 into 1 is equal to 0.2. Add them up with the initial w2 value. W2 initially it was 0.2 minus 0.2, and now we got plus 0.2, so the weight will become 0. Now w1 is equal to 0.5 and w2 is equal to 0. This weight we will be updating it here and using it in the next equation. So in this equation again we'll do the same thing. This same thing will copy paste here, and again we'll calculate the values with the new weights. Here with which weights we calculated? 0.3 and minus 0.2, the initial weights. Now we'll calculate here using new weights, which is 0.5 and 0. Based on this we'll calculate again and we'll get some answer. Now this answer, there is this one is fixed, 1 and 1. I mean, sorry, this is also not fixed. With the updated new weights also, I'm getting 1 here, and but here it is 0 only. So here again error is there, 1 minus 0. And here another error occurred. 0 was here, but 1 came an answer here because of new weight. So the error will be 0 minus 1, which will be minus 1 here. Again, we'll be writing the same here, 0.5 and 0.5. Whenever change is needed, we'll be first doing this change. Okay, for the input 10 will be doing change, same value will be applying with the new updated weights, and we'll get an updated weight. That updated weight will be using and calculating this value. Okay, when we'll be calculating this value, we'll be again, we have got another wrong answer only here. So again we'll update the weights. Okay, for 1 and 1 also we'll update the weights, and we'll get another new weights here. So the weights new are 0.5 and 0.2. So we'll be writing 0.5 and 0.2, and we'll be calculating. Again we got a wrong answer here, and we'll be calculating it, means updating the weight again, and we'll be doing the epoch 4, means fourth iteration. In this iteration, when we see with the weights as 0.3 and 0.2, the weights are matching the desired output here, so there is no error. When there is no error, the final weights will be taken, and that's your final answer. So finally you have to write this much to get 12 marks. Okay, this thing you need to write. If you don't write, you'll be losing the marks. Okay, and these are the steps you need to follow. Okay, now Delta is the difference between the desired and estimated output. Got the point? What is the desired output? Desired output is 0001 and estimated output is after calculating what value we got. Okay, the difference between them is delta. Okay, and this is the formula for the training error, and this is the principle of gradient descent. It is an optimization approach used to minimize the cost function by converging to local minimal point. Okay, by converging to local minimal point, we'll be optimizing it. That is called as a principle of gradient descent. Okay, and using this we'll be able to find out the optimal answers. Okay, now there are different types of artificial neural network. Okay, different models are there. The first one is feed forward neural network. Feed forward means the input comes from here and we'll calculate and keep moving forward. Okay, that is feed forward. Okay, always it will move forward and it is complex. Okay, you cannot calculate means easier answers. Okay, it cannot calculate easier answers. Okay, and here we'll be able to calculate only basic answers. Next one is fully connected neural network. Here every node is connected to every other node in the layers. This is connected to this and this and this. Okay, like that all nodes are connected to all nodes. Okay, that kind of layer is called fully connected neural network. Okay, next is multi-layer perceptron. Here we'll be having different types of layers. Okay, and these layers, they will be going back and forth. Okay, so the forward direction by multiplying input weights will be moving the weight forward, and backward direction, if it is wrong, will be moving backward and updating the weights and again coming back. Okay, that is happening between one layers. Okay, so the single layers, if it is happening, it is called multi-layer perceptron. If it is happening between more layers, more than one layer, if it is happening from the output also it is coming, that is called as the feedback neural network. Okay, because back and forth in multiple layers it goes. Okay, so this is the model of a feedback neural network. Okay, next we have applications of ANN, artificial neural network. Real-time applications of face recognition, emotion detection, and self-driving cars, etc. Business applications, stock trading, sales forecasting, customer behavioral modeling, banking and finance, education, healthcare, other engineering applications. You can go through it. You can remember few of them, and if you write, that is more than enough. Okay, next is advantages and limitations of ANN. It can solve complex problems. Okay, it can learn and recognize complex patterns. Parallel processing is possible. They have an ability to work with inadequate knowledge. Lesser knowledge also they can work and generate the similar responses, and they can scale well to larger data sets. Limitations require that it requires processor with parallel processing capability to train, like higher capability is required, and also large amount of data is required. Okay, and the second limitation is they work like a black box, which means we don't understand how it's working actually. Okay, because it happens very complex way and very fast, so we don't actually know how it's working and what is the relationship between the variables. Okay, so that is one limitation. If you found this video helpful, please like and subscribe. It helps me make more videos like this, and thank you so much for watching. I'll see you in the next one.